Hello and welcome to this second lesson into our work about the Galapagos Islands. The Galapagos Islands didn't exist 5 million years ago, so how did they form? There's some clues on that initial PowerPoint slide. Take a minute, just have a think. What do they show? What do we know about this already? What possibly could that answer be? Once you've done that, I'm going to set you on a 15-minute starter task. This is a real recap on previous learning. Some of it you may have to really stretch your brains to remember, but this is really good knowledge that links to what we're doing today. So firstly, draw an annotated diagram of the structure of the Earth. Once you've done that, draw an annotated diagram of convection currents. Think lava lamps here. Once you've done that, there's some map skill work. There you'll see the Galapagos located on the Nazca Plate. And what you want to do is answer those questions about the direction of movement between the Nazca Plate and the South American Plate, and the Nazca Plate and the Pacific Plate. What type of plate is the South American Plate? The clue is that there's land there. What type of plate is the Nazca and the Pacific Plate? Well, look what that covers. What type of volcano would you find between the Nazca and the South American? And what type of volcanoes will be found at the plate boundary between the Nazca and the Pacific? Once you've done that, thinking of those answers, which should have jogged your memory somewhat, could you then draw an annotated diagram of the plate boundary between the Nazca Plate and the South American Plate? And then can you draw an annotated diagram of the plate boundary between the Nazca and the Pacific? Once you've done all that, look at that image where the Galapagos are. Are they found on a plate boundary? If they're not on a plate boundary, how did they form? Pause the video. Once you've done all that, come back. It should take you about 15 minutes. Okay, welcome back. Let's see how we got on. The answers. Firstly, your structure of the Earth. You should have had your core, your outer core, your mantle, your crust. You should have separated that into the oceanic and the continental crust, which is some of the answers later on. Maybe you've got the lithosphere rather than crust, which would be really clever geography. And that's what you should have got. You should know that the core is the hottest part of the Earth and the innermost part of the Earth. Convection currents then link to this. Here you can see how the mantle is heated up, it raises, it slides underneath the crust, and as it does that, it moves the tectonic plates. In this diagram you can see the mid-oceanic ridge, it's moving away from each other, and as it moves away, it goes towards that subduction zone, which is where the oceanic subducts under the continental. These convection currents make the tectonic plates move. Some answers. Well, the Nazca Plate and the South American Plate, they move towards each other. The Nazca Plate and the Pacific Plate, they're moving apart. You can see the arrows there. The type of plate for the South American Plate is a continental plate, landmass, and the plates for the Nazca and the Pacific Plates are oceanic. The type of volcano you'll find is a composite. It's highly explosive, and the ones that you find between the Nazca and the Pacific Plate are shield, gentle and frequent eruptions. Here's our destructive plate boundary then. This is what you should have drawn. You should have your oceanic crust subducting underneath your continental crust. It does this because it's more dense, it's heavier. As it does this, it melts, it forms a magma chamber. And this magma chamber, it rises. It rises through the crust, forming this composite volcano, which explodes frequently in a violent way because it's made of, this magma is very explosive, high in silica, high in gas. The other plate boundary is the opposite of destructive, it's constructive. Here you've got two oceanic plates. You can see they're moving apart from each other. They move apart from each other because there's convection currents taking one plate one way and the other plate the other. This creates something called a mid-ocean ridge, and in that you get magma rising. And this is where volcanoes are formed. In this case, shield volcanoes. So are the Galapagos found on a plate boundary, which would explain how that landmass was formed? Well, the answer is no. They're in the centre of the Nazca Plate. But you saw in those starting images that actually they were formed because of volcanoes. So how is this? Let's find out. Today's objective, how did the Galapagos Islands form? Firstly, what I want you to be able to do, describe the structure of the Earth and how convection causes plates to move. Describe the tectonic activity occurring either side of the plate the Galapagos sits on. If at this point you need to pause the video, go back to the work you've done as a starter and refresh it and redevelop it and improve it, then that's fine. Feel free to pause the video now and go and do that. For secure though, I want you to now be able to explain the concept of hotspot volcanoes, how they're formed using accurate geographical terminology, then apply this geographical theory to the Galapagos to show how these islands were born. I'm obviously asking you to use your prior learning and apply it to new ideas, and I want you to show some real resilience. Some of this does take your minds back to year 8, a long time ago when we did tectonics, but you need to be really willing to learn today. So, how are they formed? I'm going to show you a video. This is going to be just for 2-3 minutes, and it's going to explain to you about how islands are formed. This will be really important, not that you take any notes, but just that you watch and take it in and understand. This will help you with your next task.
While the surface of the ocean is still 2 miles up, the volcano spews out enough lava to create a first platform. This becomes the foundation of an undersea mountain. As it rises, the volcano's mood shifts. The closer it is to the surface, the less pressure there is, leading to a greater magnitude in the explosions. It stains the water with sulfur. When the erupting magma comes into direct contact with a body of water, the very large contrast in temperature causes both the water and the magma to explode. Miles offshore, the hotspot creates an island.
Okay, I'm just going to pause the video there. That should give you your first ideas about how the Galapagos were formed all those millions of years ago. To reinforce this, your next task is to read the 8 statements which explain the formation of the Galapagos Islands. These are on the sheet that was uploaded. If you haven't got access to this sheet, then I will put these on the Teams now. They're not in the right order. What you need to do is put them into the right sequence. To do this, very simply number them 1 to 8 so that you know which order they should go on. And they explain the formation of the Galapagos Islands. Pause the video here, come back when you've done that. Okay, welcome back. So, let's see if you got them right. This is the order that you should have got them. The interaction between the tectonic plates and a hotspot form the Galapagos Islands. A hotspot's a region of intense heat within the Earth's mantle. The hotspot theory starts to explain this formation. The Galapagos hotspot is currently located beneath the northwestern region of the Galapagos archipelago. So around those islands, it's the northwest. Fernandina and Isabella. It's very wide, it's 150 kilometers or 100 miles wide. A hotspot is fixed under the Earth's crust and rises. It is exceptionally hot, and due to this, it can deform and break through the crust at points, particularly where the crust is quite thin. So it almost punches its way through the crust. Where the hotspot breaks through, new land is formed. You saw that in the video, and these can often be volcanoes. They continue to erupt and build further and further and make the land wider. Because the plate is still moving though, these newly formed islands slowly move away from the hotspot, and it makes more room for new islands to be formed. Since they're all formed underneath water, the material forming builds and accumulates and spreads out like a sandhill. This creates very wide, very gentle sloped sides, but these volcanoes, you've seen them before, they're another example of a shield volcano. This process formed a chain of volcanic islands, and it's home to some of the most exotic flora and fauna in the world. So flora is plants and fauna is animals. These plants and animals are exotic because of their isolation. When the Galapagos were first formed, they were 600 miles away from the mainland, a new island that developed its very own evolutionary process. The Galapagos is a stationary hotspot, so that doesn't move, forms this chain of volcano as the Nazca crustal plate moves east-southeast above the hotspot. It's like a conveyor belt. It's constantly moving. It moves at 5 centimeters a year, and we know this from our theory of plate tectonics. This means that more volcanoes and more islands are formed, meaning the oldest islands are found the furthest away from the hotspot, and that's in the southeast. The more recently formed islands are in the northwest, and the most recently formed island is Fernandina. It's about 500,000 years old, but that makes it pretty young in geological terms. The nearest island to the Galapagos hotspot, that is. It's still very young, it's still erupting. The last known eruption was in 1998. Check your answers, make sure you got them in the right order. Once you've done that, I want you to really show your understanding. These two images will help you. There's an image that helps you to think about what a hotspot set of volcanoes looks like. And there you can see the Galapagos Islands. And you can see that to the left of it in the west, that's Isabella, and that's where our newest islands are. What I'd like to do is use the 8 statements you've been given. You've got them in the correct order. I'd like you to try and draw a visual representation of what is happening, and therefore you'll be able to explain the formation of the Galapagos Islands. Pause the video and I'll come back to you very quickly. Okay, welcome back. Let's see how we've got on them. Can you now describe the structure of the Earth and how convection currents cause plates to move? Hopefully you can. Can you also describe the tectonic activity occurring either side? So can you describe the destructive boundary and the constructive boundary? It may have taken some time to refresh your memory, but hopefully that's all coming back to you. But now can you now explain how hotspot volcanoes are formed using accurate geographical terminology? And does your storyboard actually link to that theory directly to the Galapagos Islands? If it does, you've done brilliantly and you've used some prior learning and you've applied it to new ideas. And you've also shown an amazing ATL to show some resilience on what is quite a difficult set of ideas and a real willingness to learn. So well done. Finally, here's the Galapagos Islands. Just have a think. What will that look like in 1,000 years' time? What's it going to look like in 500,000 years' time? What's going to happen to San Cristobal? What's going to happen to Isabella? Is it going to be the newest island still? What will replace it and why? Have a think about those answers and make a note. This really shows your understanding.